And once again, welcome to everyone in the room. We're looking forward to a thorough discussion of implicit bias in STEM and academia today. If you have trouble hearing throughout the event or you run into technical difficulties, let us know in the chat window. I'll be attending the event throughout the hour to provide assistance as needed. And if you are new to CIRTL, I also want to take a quick minute to welcome you on behalf of the CIRTL Network. We are the Center for the Integration of Research, Teaching, and Learning, and we're a nationwide network of universities. And not only are we stretched across the U.S., we also have a member university in Canada. So as we talk about issues of bias and diversity and inclusion and equity, we're having those discussions with a huge diversity of perspectives because of the nature of our network. So I really want to encourage people to not be shy and to chime in throughout the event today because your experiences will help make this event valuable. At the CIRTL Network, we teach STEM grad students and postdocs effective, inclusive teaching methods so that they can become both excellent researchers and teachers. And again, today's event is very much in the spirit of that theme. And if you're looking to learn more about what we do, you can read more about us at our website. So thanks everyone for coming today. If you have trouble hearing or if you run into technical difficulties, let us know in the chat window. And there will be a couple interactive moments throughout today's session, least of which is our Q&A and discussion after we hear from today's speaker. When we get to those interactive moments, we'll be sure to also give you directions on how you can interact effectively in this online space. So with that, I want to hand things over to Caitlin Martin and Jessica Alexander of IUPUI, who can introduce today's event.
Thank you for that introduction, Kate. Hi, everybody. My name is Jessica Alexander, and I'm an instructional consultant here at the Center for Teaching and Learning at IUPUI. And I'll be facilitating today's session with Caitlin Martin and Ann Borden, who are both graduate assistants here in the Center for Teaching and Learning. And they have both been quite instrumental in getting the CIRTLcast off the ground. So I'm very thankful for all their efforts. And so before we do some introductory activities, Ann is going to introduce our guest speaker for today. So I'm going to turn it over to her.
Awesome. Thank you, Jessica. All right. So today we have Dr. Sarah Eddy. She is an assistant professor in the Department of Biological Science and the STEM Transformation Institute at Florida International University. She received a Bachelor's of Science in Biological Sciences from Purdue University and a PhD in Zoology at Oregon State University. Dr. Eddy completed a postdoctoral scholarship in biology education with Dr. Scott Freeman, Allison Crow, and Mary Pat Wenderoth at the University of Washington. Trained as a behavioral ecologist, Sarah has shifted from studying behavior in a field setting to behavior in college classrooms. Her research focuses on understanding how college instructors can contribute to the goal of equal participation of historically underrepresented groups in science careers, specifically by documenting current disparities in student college experiences and working with faculty to deploy classroom interventions to addressing these. In addition to scholarly publications, Dr. Eddy's work has been featured in the New York Times, The Atlantic, Science, and Insight into Diversity. So now I'm going to hand it back over to Caitlin and Jessica for some activities.
Awesome. Thank you so much, Ann. So we have, similar to last time, to those of you who joined us, we have a box folder with some resources in it. If you go to this link, you should be able to access it. It will include the PowerPoint presentation from today, a series of key terms, the same that we provided last time. It's for all the sessions. An empty outline, which you can fill out as we go through some of the questions here, as well as a series of research highlights. Within the references, we have included some on intersectionality, which is something we'll talk a little bit about now, but that is as a follow-up to session 1, and we'll get into that next. Oh, actually, we're going to start with some polls. So I think Kate from CIRTL is going to help us here. So we wanted to just get a feel for our audience. So if you could go ahead and vote in the poll. We've got some votes coming in. So again, just if you're an undergraduate, graduate, postdoc, or faculty.
And folks can share their responses to this polling question by going to the top of their participant panel and hovering over this A icon to select the answer that best corresponds to who they are. If you're joining us with a group, I see we have a few different groups in the room. First of all, it would be great if you could let us know how many people are joining with you. And second of all, feel free to respond in the chat window, since I'm guessing there's not an easy poll response that matches your local group makeup.
Great, thank you, Kate. So it's looking like there is a large majority of graduate students here, which is awesome. We welcome you, and we're excited to hear your feedback. We also have a number of postdocs, as well as a few faculty members, which is great as well. So we're excited about having you all here. For our next poll, we're interested in what discipline you're in, whether or not it's science, technology, engineering, or mathematics, or non-STEM disciplines. Although this CIRTLcast series is focused on implicit bias in STEM, we're also very excited about any and all perspectives outside of the discipline. So we'll give you about a minute here to go ahead and vote. Okay, so we've had, most of you have answered the poll right now, and we see that we have a majority of people from science, as well as a few people from engineering and one person from math, so we're quite excited about that, and then a few people too from non-STEM disciplines. So we have a good mix, but majority science. So now that we've done a couple of introductory polls, we're going to be reviewing some key terms related to today's definition, the first of which is implicit bias, which we focused on a lot last week. So just a quick review, especially for those of you that may not have attended last week. Implicit bias are the subconscious thoughts that prevent us from making impartial judgments. Discrimination is the unequal treatment based on one or more identities, so whether or not that's race, gender, sexual orientation, disability, or socioeconomic status, just to name a few, that may result in discrepancies in what types of services or opportunities those people have. Prejudice is a prejudgment or negative attitude that's typically based on unsupported generalizations or stereotypes. Worldview are perspectives that are rooted in someone's histories, experiences, culture, or family. So, for example, I have a white female cisgender worldview based on my experience and my experience of the world and who I am as a person. And then finally, intersectionality is a contextual framework for systemically understanding how multiple social identities intertwine to influence experiences and opportunities. So we wanted to take a moment to delve into intersectionality for a bit. Originally we had it as the term that we were going to discuss in a later session, but it's so important that we felt that we discuss it today. So as Jessica just said, intersectionality refers to the social, economic, and political ways in which identity-based systems of oppression and privilege overlap and influence one another. So each person's identity is made up of the intersections or overlappings of multiple identities, like Jessica mentioned, such as race, ethnicity, sexuality, socioeconomic class, disability, etc. So importantly, you don't just walk through the world or experience the world as a result of one of these identities. It's really the intersection of those identities that can greatly influence how you view the world and influences your experiences. So part of why we wanted to address this today was based on some of the feedback that we got from last session. We hear you as white women presenting that you want more, and unfortunately, a lot of the research that's going on in STEM is focused on gender. And Jessica can talk a little bit more about this slide as well. In the corner here we have the general versus STEM workplace intersectionality research. Here you can see how heavily weighted that is with gender, race and ethnicity second, and then no focus is third. And as you can see, there's very, very few studies on sexuality in STEM, and only a few in more general workplace studies, and then there's none on disability. And then in the bottom two figures, the left one is just the self-reported percentage of physicists who identify as LGBTQ who experience harassment in the workplace. So you can see that that number is quite large, quite alarming. And on the right, you can see the comfort level in disclosing to someone that they have a disability, and you can see the difference in terms of if a white woman has a disability versus a woman of color. You can see how that shifts. And also, if you have a white woman who is part of the LGBTQIA community, a white woman who has a disability versus a woman of color in that bar graph. So that really gets at intersectionality. It's not you're not just a woman sharing the fact that you have a disability. Those other identities, whether you are straight, whether you are part of the LGBTQIA community, or whether you're white or a woman of color, that's going to influence whether or not you share a disability, because each of those identities have particular stereotypes associated with them that have led to large amounts of discrimination, right? So again, we just wanted to go back to say the bulk of the evidence-based peer-reviewed research that has to do with implicit bias in STEM in a context of U.S. higher education is largely gender-focused, but we want to be intentional about going beyond that. So we welcome your dialogue on the matter, and we hope that you feel free to chime in the chat box throughout this presentation, and we will also have some discussion questions that'll target that more directly. And again, we included some references specific to intersectionality in STEM within the references sheet in box. So next we wanted to summarize some ways in which we can identify implicit bias in ourselves and others. So for STEM instructors, for you if you're an instructor or if you plan on teaching in the future, it's really important to engage in reflective teaching. So asking yourself questions such as whose perspectives are included when you're developing content, what prior knowledge do you assume your students have. You can also utilize tools like the implicit association test that Dr. Ash-Bernardo mentioned in her presentation last week. We really urge you to get feedback from students, so you can utilize mid-semester feedback that's conducted by either you or a colleague at your university. And although course evaluations are useful, you can certainly use them to inform your course, but we definitely also caution to use them as sort of a grain of salt. With a grain of salt, there's a large body of research that has actually shown that end of semester student evaluations are actually better at measuring bias than they are at measuring teaching effectiveness. In your classroom, you can make inclusive teaching a priority, so not just an add-on to your course, but really integrated within everything from the course. And again, feedback from your students is invaluable. So again, if your university has a teaching center that offers some sort of mid-semester feedback service from students, I would definitely recommend that you consult your teaching center for that. And then regarding STEM students, really realize that stereotype can increase the likelihood of attrition, and we definitely recommend that you mitigate stereotype threat with stereotype replacement. So you can do this through the examples that you're using in your course. And combat microaggressions with microaffirmations. So for example, you can promote a growth mindset in your course. You can say something like, I know every one of you can succeed, and intelligence is not something that is fixed. You can, work your brain like a muscle and really communicate to your students that you believe in them. Mm-hmm. And then finally, what can we do with ourselves? So first off, really realize that as a human being, you inherently have implicit bias. Even if you work really hard at not having that bias. So as a first step, awareness is key. So recognizing things that, like, we live in a segregated society, which can really is one of the ways in which implicit bias is sort of manifested, just in the way that society is segregated. And again, engage in counter-stereotype experiences. And then finally, just being aware, we really want to emphasize that just being aware of implicit bias in and of itself is not enough. But again, awareness is the first step in a lifelong process of combating it. And we know it takes a lot of work and reflection, so we're very excited to discuss it with you further today. So we are going to pass it off to our featured guest speaker, which is Dr. Eddy. She has prepared a presentation, and we will pass it off to her now.
Great, good morning. Thanks everyone for being here. This is my first webinar, so if anything isn't working, just let me know. So I was asked to kind of talk about how we measure implicit bias. And so with my own bias as a researcher, I really focused on how researchers have been measuring it. And so I'm going to go through some of the studies and some of the study designs that have been really common. And if you have any questions as we go along, just let me know, I guess by raising your hands. Okay. So my personal background is biology education, and I have focused quite a bit of my research on gender, and the point raised about intersectionality is key. There are not a lot of studies looking at this. There are some qualitative studies, but not a lot of quantitative studies. And so that is definitely a space we need to move into. So here's what I thought we would do today in our time together. So I wanted to do a real brief review of what implicit bias is. We've done that a little bit, but I want to raise a couple key points about it to keep in mind as we go through the rest of the talk. And then I want to talk about two types of experiments we can use to measure it, and then some implications for the classroom. Why should we care about implicit bias in the classroom? And what can we do about it? And that's going to be very brief because that's what you're going to talk about more next week. Great. So another way to think about implicit bias is calling it just unconscious attributions of characteristics to a member of a certain social group. So there may be certain characters that I just assume that someone has because of what they look like or because of what I know about them. Right? And that is implicit bias. I don't mean to, it happens. These are pathways that have connected in my brain. Right? So some of the key characteristics that have already been brought up is that everyone has them, right? And they come from our environment. We're socialized into it. And it comes also from our experiences. So they're there. They're in our heads. There's nothing we can do about that, right? And we aren't necessarily conscious that we have these biases. So even in our best intentions, we can do something that has we didn't intend those consequences, but it can have them. Right, and I want to raise this point because a sticking point for some people with unconscious bias where it can be so hurtful and hard to process is that it makes us bad people. Right? Some of us feel that way, and I know I did when I first was learning about this. But the point is, we all have this, and it doesn't make you a bad person to have it. It's what you do once you're aware, right? that changes that relationship. And so I don't want us, and I know me saying this isn't going to change anything, but don't let guilt slow you down, I guess, is what I want to say here. Right. And so the other points that I really want to bring up, and that's important for these studies, is that we're most likely to act on our unconscious biases when we're stressed out, when we're tired, when we don't have our full mental resources to bring to bear on a task, and when we're making quick decisions, when we have to, because of time constraints, make fast decisions. These are the moments in our sort of work lives where unconscious bias can most come into play. Right? So keep those in mind as we go through this talk, because there's a lot of really key decisions that can get made kind of quickly, and that when that happens, that can be a problem. All right, so when we're talking about implicit bias, as a researcher, how do we measure it? Well, one of the ways we measure it, we talked about a lot. So I want to bring up two principles for these experimental designs. The first is because it's unconscious, right, and because a lot of people aren't necessarily aware they have them, you can't ask about it directly. If you ask about it directly, you're going to get explicit bias, which is different than implicit, right? It's what we consciously know. And that's a very different thing that we're measuring. Because explicitly, I can say that I don't have biases, and I can believe that, but what's going on unconsciously is different. Okay, so a lot of these study designs that are used for implicit bias have people make choices that seem unrelated to race, gender, class, or any of these social categories. And that's how you elicit the unconscious, right? And then the other thing that they do is they tend to use realistic situations. And you want realistic situations because we want these research to be informing the world, right? We want it to make a difference. And there are a lot of realistic situations where we have incomplete information about people, and yet we still have to make a decision. And so some of those situations are things like hiring, how students choose to form study groups, grading, and then situations like juries, things that really have real-world consequences for people. And so a lot of the studies will choose one of these settings and make scenarios around it. All right, so the first experimental design is one you talked about last week, but I just want to go over it quickly for folks who weren't in the session last week. So this design is the implicit association test, and it can be used to identify one's own or others' biases. So what this test does is it's a measure of the strength of unconscious associations. So just quickly how it works is they give you kind of two elements. So say we wanted to understand biases in STEM around gender. So they're going to have gender and they're going to have STEM, right? And they're going to see how quickly you associate gender, a particular gender, male or female, with being in STEM, right? And so they're going to give you a set of words that are female or male words and a set of words that are science words, or in this case, liberal arts words. And they're going to see, is it easier, are you faster at connecting male in science or female in science? Right, so roughly that's what it's doing. It's measuring how quickly you can make those associations. And the slower you are at making those associations, that implies that you don't have those ideas tightly linked in your unconscious brain. Okay? So that's just a rough overview. And so when you do this for yourself, you'll get an N of 1, right? You'll find out whether your data suggests that you have this association between female in science or male in science. So what's really important is when this is done across thousands of people, we get a sense of the average association, and those average associations can be predictive of things. And I think that is what's great about this test is that there has been a lot of conversation about the validity of the test, but it does make predictions. And we can look at the predictive validity and see if it's associated with actual outcomes when we're looking on a large scale. Okay, so some examples of these types of studies. Most of this work has been done on gender in STEM, and so let me show you a couple. NOSIC is a great researcher to look for these. So what they did is they looked at the average association between male and STEM across countries. So what's the average in each country? And then they looked at achievement gaps between men and women on math and science assessments. And they found the stronger the implicit bias about STEM being male in a particular country, the larger the achievement gap between males and females on these tests. Okay, and then the less association, right, then there were reduced achievement gaps. So there seems to be some predictive validity about this test, and these biases seem to be impacting something. What's really interesting in my own work and thinking about the experience of women in STEM is that even female STEM majors still show this bias on average, right? It's always on average. Individuals may vary, but on average. Now, this is a weaker connection than females who aren't STEM majors, but it's still there. So that's interesting. And then this may be important because they show, NOSIC in a separate study shows that the individual strength of that association predicts performance on the quantitative section of the SAT. So the stronger an individual's association of STEM and maleness with females, the lower they perform on the quantitative SAT. Okay. And then the final point I want to raise with this is that, interestingly, male STEM students show the strongest association between male and STEM stereotypes, so stronger than male students outside of STEM. And to me, this isn't too surprising because they're living it, right? They're male, they have a strong association with STEM, and so they're, in a way, they're living that bias. It's not a bias because it's their lived experience, right? And so, but thinking about being a female student in STEM and who you're interacting with in your classes, right, that's an issue, or it could be an issue, and it's something for us to think about. Okay, so that was just a quick overview of the IAT because you did it last week. And then some consequences that we can see for women in STEM who hold those STEM is male biases. Okay. The second design I want to talk about is basically providing identical qualifications but differing the social groups that someone belongs in. So the most common way that you see this play out is by CV studies. So you have identical CVs, and you make some indicator in the CV of some social group. So a lot of this work has been done around white and black comparisons, and so one of the most common things to do is to change the names so that one is a white-sounding name and one is a black-sounding name, right? And so identical CVs, but the names are different, and the names may signal to the evaluators, right, the social group that someone belongs to. Another way to do this is to slip in like a group that they're associated with, that may be a racial group or maybe an LGBTQ group or something like that, right? So that's some indicator of the social group that the applicant belongs to. So when you do the identical CV studies, you send each CV to different evaluators. So they're not getting, right, both getting the identical CV with two different names. They're only getting one. And those evaluators evaluate that person. And you do this hundreds of times so that you can get a randomized sample. And what you care about is the average rating, or say the average callback rate if it's an interview. And you compare those. So does the person with the white-sounding name, right, end up with a different average rating or different callback rate than the person with the black-sounding name? Does the person with the male-sounding name end up with a different callback rate than the person with the female-sounding name? Those sorts of things. Okay. So what do we see from these studies? There's quite a, I mean, this has a long history of being done, and so obviously I'm not going to go through all of them, but I'm going to go through a really recent one that I thought was particularly well done. So in this study, they essentially found that Black and Asian applicants who write in their name or their resume, and we'll talk about what that means, are twice as likely to be called back in for an interview than folks who don't do that, who don't write in their CV. Okay, and what does it mean to write in their CV? There's two categories here. You can change your first name, write in your first name, right? And then the other thing is to drop any of those experiences that are an indicator of racial category. Okay, so what's cool about this study is these were all real job ads that they sent these CVs out to. And they had overall 300 different job ads in each category that they did. So they had over 1,000 job ads that they responded to. And one of the ways that we can really realize that this is probably unconscious bias is they not only sent the CVs out to all job ads, they sent them specifically to a subset of job ads with pro-diversity language, indicating that these companies wanted to not have bias, right? They were interested in diversifying their environments, at least on paper, right? So what they found is that when you compare job ads with and without the pro-diversity language, it actually didn't make a difference. That you were still seeing the advantage of whitening both the name and experience. So even these explicitly, right, not biased companies who are claiming that they want to have this are still showing bias in their hiring processes, which is really interesting. And one of the consequences this study found is that applicants so they did interviews as well as sending out these CVs. And what they found is that applicants, when there's a pro-diversity statement, would not hide experiences that indicate their racial group. They believed, because that's what the ad said, that this company was not biased, was looking for this, and so they would share more of themselves than they would for a company that didn't have a pro-diversity statement. And so the unintended consequence of this is actually these pro-diversity statements were leading to fewer diversity hires and leading to people actually being less likely to call back. Okay, so indication of unconscious bias because it's overtly and explicitly, right, they're saying that they want diversity, but in the hiring process, it turns out that it's still being selected away. Okay, so that's an example from the workforce, and a recent one that was pretty good. In academia, this was a pretty famous one that came out a few years ago. They had scientists rate female applicants for like a research associate position, so someone to help them in their research lab. And again, on identical CVs, they found that scientists, regardless of gender, I should say, rated females lower on hireability, lower on competence, lower also on the amount of time they said they would spend mentoring that employee, and they would offer them less money. So these research scientists, regardless of gender, were showing a bias against female research associates in science. Okay, and so the graph popped up here, and you can see the differences in the rating of competence, hireability, and the amount that they would spend on mentoring these people. Right? And if we think about mentoring and how important mentoring can be for building someone up and helping them in their next steps for their career path, it's really a little bit devastating, right, that they would put less time in there. Right, and so the last one I want to talk about for this is actually looking at evaluation of work produced. So this is a variation on the design, but this study had these legal briefings that were supposedly made by different employees, but they were exactly the same, and they contained like 22 errors in them. So they gave them out to be evaluated, and what they found is that the raters were more likely to find the errors when the supposed writer had a black-sounding name than when they had a white-sounding name. They also scored the work lower when the writer had a black-sounding name rather than a white-sounding name. Right, so one of the authors said, well, we expect to see errors. We find errors when we expect to see errors, right? And so there was something happening, right, that made the errors more likely to be seen for black students. And that, again, likely was unconscious bias. Okay. So those are some examples of the types of studies we can use to look at unconscious bias, and I'll talk about more in a second. But I've been talking a lot and talking about work that's been done in a lot of different environments, right? So I'd love for us to just take 1 minute to reflect on this. So although most of these studies were done in the workforce setting, can you see connections between what we just went through and the classroom? So go ahead and take 2 minutes, say, and you can jot your thoughts here on the whiteboard, or you can just jot your thoughts down if you don't want to share them. But just reflect back on some of the findings that we just talked about, and how do you think those impact students, or could impact students? And I'm going to time you on my phone, and I promise I'm not using text messages.
So folks can type on this slide by going to the vertical toolbar to the left of the slide and selecting this A icon with lines next to it. Be sure you click that icon with an A and lines so that you can resize your text box. If the text box, or sorry, if the slide gets totally jam-packed and crowded, feel free to share your thoughts in the chat window instead.
So about 10 more seconds. Try to wrap up your thoughts. Great. So there's a lot of great stuff here, right? So thinking about bias and grading, thinking about how does it feel like a risk to volunteer, and who might feel more of a risk for. Expectations that we have for our students. Is there some differences there unconsciously? Things like that. These are all really great points. So thank you for sharing. Okay. So I want to point out a couple studies that kind of relate to these, and you've already come up with some of them, but there is some data backing them up, and so I want to share those. Okay. So if we look at examples of how bias influences the classroom, we can talk about bias in teachers, for example. They're one element of the classroom, right? And so there have been some studies on this. This one is particularly nice because they measured both implicit bias and explicit bias, and they tested which of those had more influence. And they found that explicit bias didn't really correlate with anything, but implicit bias did correlate with different expectations of achievement for students from different ethnic backgrounds, and most, well, it's all important. So but that matters is that the size of the achievement gaps were larger with teachers with more implicit bias than with teachers with less implicit bias. So this was not done in the US, this was done somewhere in Europe. And so it wasn't done with our racial categories. But it shows proof of concept in that teacher implicit bias can affect achievement gaps, and it can affect our expectations of our students. And they did a mediation analysis, and they did show that it was the differences in expectations that were what drove the achievement gap. Okay. So this study was done in the US, and they found that so in this study they were looking at writing and writing ability, and so they had students and their grades on standardized literacy exams, and they compared how the students did on those exams to how the teachers evaluated them. And they found that Black and Latino students were rated to be of lower ability than their white peers, even the students that got the exact same score on the literacy exam. And where this became most pronounced was at the extremes. So the really good students, if you had the same really high score on that literacy exam, if you were Black, you were rated lower than if you were white, and the difference was bigger than in the middle. So if we're thinking about who's getting put into honors programs, if we're thinking about who's being recognized as being really good at their topic, right, these biases may come into play and impact the very top even more extremely than other pieces of the distribution. Okay. And this is an example from K through 12, but I think it's important as well. Teachers, there's now a lot of evidence that in the U.S. system, teachers are more likely to suggest harsher punishments for Black students than white students for the exact same incidents. Another example of bias. But what this does is the harsher punishments tends to be expulsion or not being allowed in the classroom. And so this can actually produce problems further down the line, right? Because these students aren't in class to learn the things that the teacher is teaching. And so how does that impact them further down the line if they're missing a lot of class because of teachers having harsher punishments for them? How does that impact our students who get into college or who don't get into college, right? Another important element in the classroom is peers, and this is where I've done some of my work. We looked at college introductory classrooms, and we asked students, you know, who of your classmates is really good at biology? And they listed all their classmates that they thought were good at biology, and when we went in and looked at those lists, we found that for a female to get named, right, she had to be essentially twice as good at biology than her male peer. So for a female to be listed as often as a male with a B, she had to have an A. Okay? And this was after controlling for their actual performance in the class and also how much they spoke up in class, because we thought that a way you might get recognition from your peers is by speaking and giving good answers, right? And this was really interesting because we only saw this in the male students. Females were actually choosing their peers based, and it reflected very well their actual performance in the class. So there's not been a ton of work on peers, and so I just wanted to bring that one study up so that you had it. All right. So thinking about this, thinking about who's getting recognized, thinking about missing classes, right? Just one more time, if we could just kind of reflect on this. What impacts do these experiences with teachers and your fellow classmates mean for interest in STEM, persistence in STEM, all these things that we care about, right? And go ahead and take a minute to go through this. And again, thanks for your participation. All right, just for the sake of time, we're going to kind of pause here. But again, you all are coming up with great ideas, right? The whole metaphor of the leaky pipeline, right? Why are we losing people? It could be that it's these small, seemingly small experiences, but they're happening a lot, right? That impact. It impacts self-confidence. That's a great idea. So the concept of self-efficacy, the belief that you're good at something, one of the big contributors of that, besides personal success and experiencing that, is recognition from significant others. And those significant others are things like your peers, your professors, right? And so not getting that same level of mentoring, not getting that same level of recognition from your peers can lead to things like imposter syndrome, right, like someone is bringing up. And so these things, these biases have impacts on our students. And so it's something we really want to think about how do we help, right? How do we consider ourselves and our roles in the classrooms? Also, what do we do? How do we set up a classroom where peers are more likely to treat each other more equitably? Right? And so that's really going to be our next session. But I don't want to leave all doom and gloom because this is it's a hard topic, and we all want to make a difference, and we want to do something to change this. And so there's just a couple kind of easy things that not easy, well, that's not even the right thing to say, but simple things that we can do. Just because we have these thoughts, they don't have to control us, right? And so things like becoming aware of your own biases that you may hold. I think we talked about this last week, but you can take the implicit bias test. Another thing is just we often can't see our own biases, but other people can. And so listening when someone is generous enough to put themselves at risk by talking to you about it is really important, and it's really uncomfortable, and it feels really awful, but that person is doing it, and it's actually for your benefit and helping you. So hearing it in the moment is really important. Slowing down. So we talked about at the very beginning that we're most likely to do these things and to follow our biases when we're trying to do things fast. And academia makes you do things fast. It's just the way it works. But if you can slow down and think really deliberately about what you're doing, then they've shown that that reduces bias. Right? So taking the time. So when you are hiring someone, recognizing realistically, how much time is this going to take to go through these CVs, and setting that time aside instead of trying to rush through, right, can make a difference. Get to know people that are different than you, so you aren't relying on your internalized stereotypes, right, that you've been socialized into. When you know real people, you know that no one matches their stereotypes. And another way to do this is to expose yourself to counter-stereotypic exemplars. So female scientists, black professors, things like that. So thinking, and these are things you might bring into the classroom too. There's a great program being developed by Jeff Shinsky called the Scientist Spotlight, where he interviews and writes up little blurbs about diverse scientists. And so he brings those into the classroom, and he can show it really changes who students associate as scientists, who can be a scientist. By the end of the semester, he can influence that just with these little profiles. And finally, collect data, right? You may not be able to see it yourself, but it may come out in your data if you look for it. And so that would be my last recommendation. And you're going to get a bunch more of these next week. So I want to thank you for your time and for joining me. And I'm going to listen in on your discussion, and I would be happy to take any questions if there was time in that time point. So I'm going to turn my mic off now.
Thank you, Sarah, for that wonderful presentation. We definitely enjoyed it. So Catlin and I are going to be finishing up with a little bit of discussion and reflection. So we had a couple of questions ready for you, but we're running a little bit short on time. So we're going to skip through these to go to our final sort of wrap-up question. So what is one new thing you've learned today during today's session? And you can feel free to write on the whiteboard. Again, there's probably going to be a number of comments, so Catlin and I will most likely not be able to get to everyone's comments. So if there's something that you really want to get out and say, please raise your hand and we'll be more than happy to let you speak. You can also use this opportunity to ask Dr. Eddy any questions you might have. Again, we encourage you to use the hand-raising function if you have something you want to share. Heather, yeah, go ahead.
Hi, I apologize I don't have a camera, so I'll be kind of the disassociated talking voice here. But I had a question regarding grading anonymously. I feel like it certainly benefits students better to grade, you know, without their names associated, so that I would remove any implicit bias that I have. But at the same time, that also removes any opportunity for me to address my own implicit biases that I might have, because it just completely, you know, takes away any opportunity that I would have to recognize them in myself. So I just wanted to get a little bit of feedback on kind of that balance in addressing my implicit biases as a teacher and what the better course is to take. Thank you.
Thank you for that question. That's a great question. So first off, we're most likely to have bias against females, against people of color, against those who identify as LGBTQIA, people with disabilities, etc. Even if we're part of those groups. The other thing is that if you've been teaching for a while and you start implementing this into your course, you might see the differences in exams. So for example, in the last year in the spring semester, I did a workshop for the School of Business here, and we had an instructor who was very adamant about wanting to have an inclusive environment, and she was incredibly surprised that when she implemented blind grading, that the scores of all the female students went up in her class, even though this was something that she was really committed to. I would say that you are confronting your implicit bias by doing this, even if you think you don't have it. You're being proactive rather than reactive. It's better to eliminate it out of the gate than to run the potential for discrimination to occur in your class. Dr. Eddy, do you have anything you want to add to that? Oh, I see you talking, but don't forget to click your mic.
Now, does that work? Okay. Yeah, I think those were all great points that were raised, and I think you have to balance your student's experience, right, with your own too. So maybe looking historically, as was suggested, and seeing if you see those differences and seeing if you change if you've been using that assignment for a while. Yeah, and then can I address, there was one question about why bias might be greater at higher achievement levels, and I just wanted to quickly, there's a really cool series of papers by Leslie et al. I think they've both been published in Science that show that we associate brilliance with maleness, possibly white maleness. I'm not actually sure if they went into that, but it doesn't matter if it's STEM or not, which was really cool. They found that any field that is perceived by us to require someone to be brilliant, like philosophy, physics fell under this as well, we were less likely to see women in it. And they found that the development of male equals brilliance and that women aren't brilliant was, you could see it in kids as young as 2nd grade. They didn't have it in kindergarten, but by 2nd grade, that bias had popped up. Really interesting. But that then, right, makes, if we're adding that stereotype on top of, right, whether or not someone is good at something in general, that might mean why the top of the top is getting even more biases than in the middle.
Thank you, Sarah, for adding on to that question. So we're seeing some other comments interesting about the situation where unconscious bias can occur, so stress, hurried work, etc. Yeah, and those are situations that we're likely to be under frequently as faculty members or graduate students or administrators who are doing a lot of work. A few people have commented about how they hadn't thought about this in the context of grading. Someone commented they've graded thousands of problems, right? So one thing that I'll mention is that as a graduate student, you may not be able to implement some of these things depending on who you're teaching for and the level of control within your course. But something that you might be able to do, even if it's not on a department level, maybe if it's something that you do only for the section of your course, is to implement a rubric, because at least with a rubric, you're thinking up front intentionally about what are the things that your students should be doing and what are the points that are associated with those components of whatever you're grading. And even if that's a problem, even if it's like a math problem, okay, well, if they nail it completely, it's 100%. If they if they don't show all their work, that's only 1 point off, etc. So again, really appreciate the comments here, and so we're going to finish up here. And if anybody else wants to raise their hand, again, we welcome your comments. We're going to pass it off to Kate Diamond shortly, but we just wanted to do a final reminder about all the resources that are in that box folder. As well as our next session won't be next week, it'll be the following week, so we'll have a week break, October 22nd.
Thanks so much to Catlin, Jessica, and our speaker today, Dr. Sarah Eddy, and thank you to everyone who attended today's session. We really appreciate you engaging with our discussion and following along in the chat window and adding comments to the whiteboard. These slides will be available in that box folder after today's event. And in the meantime, I want to share a few reminders. You can find all the resources connected to today's event on the event webpage, which is the first link on this slide. We asked that folks also let us know what they thought. You may recall at the beginning of the event, Catlin and Jessica began by talking about some specific issues that came out of last week's evaluation. So we really do take your anonymous feedback seriously. You can tell us what you thought in this link evaluation right here. I'll also email that out to everyone who attended after today's session. If you're attending with a group, please feel free to share that evaluation with everyone in your group. And we do have 2 more events happening in this series, one on October 22nd on minimizing implicit bias in academic communities, and our 4th and final event on October 29th on interrupting and mitigating implicit bias when we witness it. So thank you all very much for coming to today's event. We'll be in the room for a few more minutes, so if you have any burning, lingering questions, please feel free to share them. Otherwise, have a wonderful rest of your day, and thanks again for attending, and thanks for engaging with CIRTL on this important issue. Bye, everyone.